.NET, a unified platform for modern applications. Agenda: Application platforms. .NET history. Why .NET? Application execution lifecycle. Getting started. Basic workflow. Building and running. Application platforms. An application platform gives developers a runtime, a set of libraries, and tooling, so they don't have to build everything from scratch. If a bug slips through, the runtime's type system and exceptions catch many mistakes long before they reach production. Almost every enterprise application relies on some kind of managed platform rather than raw machine code. Any team shipping software across multiple operating systems benefits from a platform that abstracts the differences away. Re-implementing memory management and core libraries for every new project doesn't scale. Managed and native runtimes. A native runtime compiles directly to machine code for one specific platform with no intermediate layer. A managed runtime like .NET compiles to an intermediate language, then a virtual machine executes and manages it at runtime. Native C, C++, Rust compiled per platform. Managed .NET, Java, JVM runs on a virtual machine. Problems without a managed runtime. Single point of failure. A manual memory bug can crash or corrupt the entire process. Every platform needs its own separately compiled and tested binary. Verbose boilerplate is needed just for basic tasks like garbage collection or type safety. Slower to onboard new developers into a dense unmanaged codebase. Harder to share code cleanly across different application types, web, desktop, mobile. Misses out on a unified ecosystem of libraries, tools, and language interop. The .NET Platform System. Source code is written in C Sharp, F Sharp, or VB.NET and kept in a source or Git repository. The compiler translates source into a common intermediate language, CIL, packaged as a .dll or .exe. The .NET runtime, just in time, JIT compiles that intermediate language into native code the first time it runs. Other similar managed platforms, Java, JVM, Node.js, Go, .NET advantages. Runs the same way on Windows, Linux, and macOS thanks to the cross-platform runtime. Speeds up development with a huge standard library (VCL) and NuGet package ecosystem. Strong typing and compile time checks catch many bugs before code ever runs. One platform covers web APIs, desktop apps, mobile apps, and cloud services alike. Excellent tooling through Visual Studio, Rider, and the .NET CLI, backed by Microsoft's long-term investment in a large open source community. Everything is managed, almost. One huge benefit is that in .NET, almost all memory managed automatically by the garbage collector. Strong typing means most mistakes are caught by the compiler, not discovered at runtime. Assemblies package code, metadata and versioning information together in one unit. Dependency injection is built into the framework, making testable, loosely coupled code the default. A single build can target multiple platforms through .NET's cross-platform runtime. Classes and interfaces. Classes bundle data and behavior together into a single reusable type. Interfaces define a contract that any implementing class must fulfill. Program.cs, a minimal ASP.NET Core API, declares one endpoint in just a few lines. Dependency injection. Here, a service is registered once and injected wherever it's needed. History. Announced by Microsoft in 2000 and released as the original .NET framework in 2002 alongside C#. .NET Core launched in 2016 as a cross-platform open source rewrite breaking from Windows-only roots. .NET Core 3.0, .NET 5, and beyond unified the framework into a single .NET platform in 2020. The Marine and later .NET OUI extended the platform to mobile and cross-platform desktop apps. Now fully open source platform framework. Cross-platform framework developed openly on GitHub. Why .NET? Cross-platform. One codebase runs on Windows, Linux, and macOS. Performance. A modern, just-in-time JIT and ahead-of-time compilation options rival native code. Productivity. Strong typing, rich IDE tooling, and a huge standard library. Versatile. Covers web, desktop, mobile, cloud, and game development. Open source. Developed transparently on GitHub with an active community. Backed by Microsoft's long-term commitment and enterprise support. The .cs project file. The .cs project file declares the project's target framework, dependencies, and build settings. NuGet package references live here, resolved automatically on the next build or restore. The bin and obj folders hold build output and should never be committed to Git. Multiple projects are tied together in a .sln solution file for larger applications. The .NET application lifecycle. Edit.cs file, write, .NET build, compile, runtime, just in time, .NET run, execute. Source is written, compiled to a portable intermediate language, just in time compiled to native code, and finally executed by the .NET runtime. Getting started with .NET. This leads us to the three commands that get a project off the ground. .NET New. Create a new project from a template. .NET Build. Compile the project and its dependencies. .NET Run. Build and run the application in one step. Basic workflow. Author a .NET application, a project, execute it, optimize it. Building, running, and testing. Some call build, run, and test .NET's everyday loop. Fast, incremental builds only recompile what actually changed. .NET Run builds and launches an app in a single command. .NET Test runs a project's unit tests directly from the CLI. NuGet Restore pulls the dependencies automatically before every build. Supports many workflows, web APIs, background services, desktop apps, cloud functions. Works the same across every OS, the .NET SDK support. Any questions? Thank you.